We have already seen what is complete bipartite graph. That is your a bipartite graph in which every vertex of part A is adjacent to every vertex of part B. For example, this is your K26 because these are the two vertices in part A, these are the six vertices in part B, and you can notice every vertex of part A is adjacent to every vertex of part B. Okay, so finally I can say that this is your so this is the concept of complete bipartite graph. Graph is set of vertices and set of edges, right? Graph is set of vertices, set of edges. Now a bipartite graph, in a bipartite graph, this V is basically A union B. You have two parts of in bipartite graph. So that is the reason I can say that in bipartite graph what will happen. Remember, you know that in bipartite graph, you know that we partition the vertex set. This we partition into two partitions. Okay, so the bipartite graph we can write like this: G A comma B E. Normally the graph is set of vertices, set of edges. This is the normal graph. But a bipartite graph, in a bipartite graph, the vertex set we partition into two parts. There are two parts. For example, this is a part, this is a part. Okay. For example, this is a part, this is a part. So I can say in a bipartite graph, we have two parts. So we can write like this. Okay. Anyway, this is just a notation. You don't have to worry about. Now the question is maximum number of edges in a bipartite graph on n vertices. What do you think? What is the answer? For example, if I ask you, what is the maximum number of edges possible in a bipartite graph on 4 vertices? Then what that will be? Tell me one thing. What is unknown here? What information is unknown? In this question, what information is unknown? We want maximum number of edges. This is what we want. But what information is unknown? Cardinality of both sides. Very good. This is unknown. Like what is the cardinality of two parts? Because this is your number of vertices. So I can say number of vertices is 4. But we don't know. Okay, what we do? Because this is a bipartite graph. So what we do? This vertex set we divide into two parts. This vertex set, what we do? We divide into two parts, A comma B. Now we don't know. For example, if I give you particular A comma B, if I give you particular A comma B, for example, if I give you one vertex here and 3 vertices here, then tell me what is the maximum number of edges you will get? What will be the maximum number of edges? If one vertex here and 3 vertices here, then the maximum number of edges will be 3. So I can say maximum number of edges, that will be 3 if I do this. But from this question, we don't know what is the cardinality of two parts. We don't know. Okay. So for example, if I do this like 1 comma 2 I put here and 3 comma 4 I put here, then what will be the maximum number of edges? Now the maximum number of edges will be 4. Now the maximum number of edges will be 4. So this is the idea. This is the idea of this question. So in this question, what will be the answer? The question is asking, you have a bipartite graph on 4 vertices, then what is the maximum number of edges? So the final answer, what that will be? The final answer, that will be 4. Because whatever you do, only this you can create. Only this you can create. Like this 4 is the maximum. You cannot create more than this. Is this question clear? I just want you to understand the question. Is the question clear? Maximum number of edges in a bipartite graph on 5 vertices. Let's see this question. Let's see. On 5 vertices. Now, what this question is asking, you have a bipartite graph on 5 vertices. So remember, your graph is bipartite graph on 4 vertices. So this is your vertex. This is your set of vertices. Here you have two part A comma B, and this is your set of edges. This is a bipartite graph. The question is asking maximum number of edges. This is the question asking. Now, which information is unknown? Which information is unknown? The information that is unknown is what is the cardinality of A comma B. This information is unknown. For example, if I ask you this question, that you have a bipartite graph. If I ask you this question, you have a bipartite graph. Okay, and there are, let's assume 7 vertices. 7 vertices, 3 in part A, 3 in one part, and okay, 4 in part B. 4 in part B. or maybe I can say maybe 5 in part A and 2 in part B. If I give you this question, so you have a bipartite graph. Your graph is a bipartite graph in which you have two parts, A comma B. These are the two parts and these are the set of edges. And what I'm saying, this is your vertex set. Now tell me, now what is the maximum number of edges? For this question, what will be the maximum number of edges? Tell me for this question. Now in this question, this information we have total 7 vertices, 5 in part A, 2 in part B. So in this part, you have total 5 vertices. Okay. And in this part, you have total 2 vertices. This is your part A, this is your part B. For this question, what will be the maximum number of edges for this question? Now for this question, answer will be 5 into 2, 10. Because we want maximum number of edges. This is what we want, maximum number of edges. So what you can do, you can create a complete bipartite graph on 5, 2. This you can create. You can create a complete bipartite graph. This is what you can do. Like this you can do. Correct? So you can create this complete bipartite graph and the answer will be 10. Is this clear? Because here we know how many vertices we have in part A, how many vertices we have in part B. This information we know. Part A has 5 vertices, part B has 2 vertices. So maximum number of edges. How to get maximum number of edges? How to get? Tell me how to get maximum number of edges? Create a complete bipartite graph. To get maximum number of edges, if you want to get maximum number of edges, then create complete bipartite graph. Then create complete bipartite graph if you want to get maximum number of edges. So this is the idea. Okay. Yes, minimum number of edges is 0. Minimum number of edges is 0. So anyway, so if you want to get maximum number of edges, then you can create complete bipartite graph. Now in this question, which information we don't have? In this question, we know that total number of vertices is 5. In this question, we know total number of vertices is 5. But we don't know how many vertices are in part A, how many vertices are in part B. For example, the part A, okay, we don't know which will give us, like, we don't know which situation will give us maximum number of edges. We don't know which situation will give us maximum number of edges. For example, will this situation give us maximum number of edges? Okay, will this situation give maximum number of edges? Like, which situation will give maximum number of edges? Which situation is going to give maximum number of edges? So you can notice here, what is the maximum number of edges? Tell me here, what is the maximum number of edges? That will be 4. Here the maximum number of edges that you will get is 4. Here the maximum number of edges that you will get is 6. That will be 6. Here the maximum number of edges that you will get will be 6. Okay, and here the maximum number of edges that you will get is 0. Correct? So this is the idea. Okay, is this clear? Is it clear to everyone? So finally, for this question, what will be the answer? Finally, for the final answer, what is the final answer? Because we want maximum number of edges when you have 5 vertices. So this situation will give us maximum number of edges, this situation. So the maximum number of edges you can get is 6. This is what I'm saying. You have 5 vertices, and with 5 vertices in a bipartite graph, you can get maximum number of edges 6. You cannot get more than 6. This is the maximum number of edges you can get. Is this question clear? What this question is asking, is that clear to everyone? Let me know. Now let's solve this question. So we want maximum number of edges. This is what we want in a bipartite graph on n vertices. So your graph is bipartite. In your graph, this is your vertex set, and these are the 2 parts A, B, and you have edges. And the cardinality of vertex set is given to you as n. This is given to you. Then what is the maximum number of edges we can get? What that will be? Okay. So here what we can do, see, we don't know which situation will give us maximum number of edges. We don't know. So what we have to do, you know that if you have A, if you have B, if you have A, you have B, then what is the maximum number of edges? Please tell me. Then what is the maximum number of edges? If you have A, you have B, then that will be number of vertices in A multiplied by number of vertices in B. Yes or no? Yes or no? This will be the maximum number of edges if A is this, B is this. We don't know how many vertices are in A, how many vertices are in B. So what we want to maximize, this is what we want to maximize. We want to maximize, okay, cardinality of A multiplied by cardinality of B. This is what we want to maximize. This parameter we want to maximize, correct? This parameter we want to maximize. Let us assume that A has, let us assume that A has m vertices. Let us assume, then what will be the number of vertices in B? Then what will be the number of vertices in B? That will be n minus m. So what we want to maximize? We want to maximize this value. This value we want to maximize. Is this clear? I am going very slowly, step by step. I am going step by step. This parameter we want to maximize. We don't know how many vertices are there in A. We don't know how many vertices are there in B. But we want to maximize. We know, okay, that the maximum number of edges will be this. Okay. Now finally, what we want to maximize? We want to maximize this value. Our target is to maximize. This is what we maximize. We want to maximize. What is variable here? In this value, which is variable? This is called, this is fixed. This is fixed. This m is a variable. This m is a variable. Okay. This n is fixed. So we want to maximize. Then what we do? See, you will study in calculus. In calculus subject, you will study this. In calculus, you will study. Don't worry about it. In calculus, you will study. There is something called maxima minima. This maxima minima concept you will study in calculus. Okay. So if you don't understand this, what I'm going to do, if you don't understand, don't worry about it. In calculus, you will study maxima minima. After that, this question is very easy, extremely easy, this question. Okay. So anyway, what we will do, so this is the parameter we want to maximize. This f equal to m into n minus m, and this is what we want to maximize. Now to maximize this, then what we do? Then we do df dm, because this m is the variable. M is variable, right? How many vertices you put here, that is variable. How many vertices you will put here, that is variable. That is not known. We don't know that. Okay. So finally, what we will do? We will do this. We will do differentiation with respect to the variable. We will do differentiation with respect to the variable. So what I will get? So this is basically d dm mn minus m square, and that will give me n minus 2m. That will give me n minus 2m. Okay, so this is what we will do. Basically, we will do the differentiation. This differentiation we will do to maximize. Remember, to maximize, we do the differentiation. This you will study in the maxima minima. So don't worry about it if you don't understand. Okay, just chill, don't worry. So this differentiation you do, you will get this value. Now, what we do, the second thing, what we do, we put this equal to 0. We put this equal to 0. We put this equal to 0. So from here, n is equal to, m is equal to n by 2. So from what we will get m equal to n by 2. So this will max, this value, so this value will maximize. So if you want to maximize, then this value will maximize. So remember, finally, this is the point. If you want to get maximum number of edges, so this is the final point, that m should be equal to n by 2. What it means? It means here you should have n by 2 elements, and here also you should have n by 2 elements. Okay, very simple. Both sides you must have n by 2 elements. Means their cardinality must be same if you want to maximize. So this is the final conclusion. You have a bipartite graph. You have a bipartite graph. Remember, your graph is bipartite. Okay. So your graph is bipartite. G, A, comma B. These are the partition. These are the partition, and this is the number of edges. What you will do if your n is odd? If n is odd, then what you will do? Then it is very simple. Just put, for example, if n is 7, then what you do? The simple n by 2 element you put here, n by 2 element you put here. Just put n by 2, n by 2 here. So what you do here, you can put 3, here you can put 4. So on one side you put n by 2 floor, on one side you put n by 2 seal. So if your n is odd, then what you do, you put on one side you put n by 2 floor, on another side you put n by 2 seal, because total number of vertices should be n. So this is easy. For example, if you have 7 vertices, then you can put half vertices here, half vertices here. Is this clear? If your n is odd, then you can put half of them here, half of them here. So on one side you can put this floor, on other side you can put seal. Okay, clear? So this is the conclusion. If your graph is bipartite, in which you have 2 parts, this is the vertex set and you have 2 parts, and this is given that vertex set has number of elements. So these are the number of vertices. Then how to get maximum number of edges? Then to get maximum number of edges in bipartite graph, to get maximum number of edges, then what we will do? To get maximum number of edges, what we will do? We will basically, this is what we will do. We will put half elements here and we will put the remaining elements here. We will put half elements here and we will put remaining elements here. Okay, this is what we will do to get to get maximum number of edges. So what will be the maximum number of edges? That will be this multiplied by this. Correct? This will be your maximum number of edges. N by 2, basically half. Okay, what you can do, if you have 7 vertices, you can put 3 here, 4 here. This is what you can do. So just put half. Okay, just put half. This will give you maximum number of edges, and this will be the maximum number of edges in a bipartite graph on n vertices. If your bipartite graph has n vertices, then this is the maximum number of edges you can create. Is it clear to everyone? Tell me, is this clear? Any doubt, anyone? Very simple question. Let me know. Okay, so let's see now. So remember, if you have n vertices bipartite graph, if you have n vertices bipartite graph, then what is the maximum number of edges you can get? N vertices bipartite graph can have maximum number of edges. What? N vertices bipartite graph can have maximum these many edges, like n by 2 whole square, these many edges, n by 2 whole square edges. Let's assume n is even. Okay, let's assume n is even. Okay, so n is even. You can just assume that n is even. Okay, anyway, what I'm saying that, so if you have approximately, this is the maximum number of edges. Okay, now, so tell me, if you have n vertices bipartite graph, then maximum these many edges you can have. This is the maximum number of edges you can have, n by 2 whole square, or I can say that n by 2 floor, n by 2 seal multiplication. This is the exact value. This value is the exact value. Okay, now, so tell me one more thing. If a graph has more than these edges, then what you can say? If a graph on n vertices, has more than n by 2 whole square edges, then it cannot be bipartite. So this is very simple. It cannot be bipartite. Yes or no? So if you have a bipartite graph on n vertices, then maximum these many edges can be there. Let's assume n is even. Okay, then maximum these many edges can be there. If your graph has more than these edges, it means it cannot be bipartite. Okay, so this is the simple point. So remember, n vertex graph with more than these edges is not bipartite. This we have proven. Okay, so very simple. And this we have already seen in the last class. K regular bipartite graph. This also we have seen. See, G is bipartite if and only if all its component bipartite. Yes or no? G is bipartite. So can I say if G is bipartite, for example, is this graph bipartite? Let me give you a graph. Is this graph bipartite? Tell me. This graph. Look at this graph. In this graph, you have odd cycles. So this is not bipartite. This is not bipartite because you have odd length cycle. So this graph is actually not bipartite. A, B, C, D, E. So if you try to, for example, let's try to create a bipartition. So if I put D here, I will put E here. If I put A here, then B is, now there is nowhere to put C. So where to put C? So I can say this is not bipartite. We cannot put C. So this graph is not bipartite. Yes or no? And what about this graph? If I give you this graph, A, B, C, D, E, F, G, H. Is this graph bipartite? Tell me. In this graph is bipartite. Why? Because there is no odd length cycle. There is no odd length cycle. We don't have any odd length cycle. So this graph is actually bipartite. So what will be the partition? What will be the partition? Partition will be like this. If I put A here, then B will go here, C will go here, D will go here. If I put E here, then F will go here. If I put G, then I can put H. For example, I can put G comma H here. I can put G here, H here. Okay. So this bipartition will work. Yes or no? This bipartition will work. This partition will work. Correct? So this is what I'm saying. A graph is bipartite if and only if each component is bipartite. Okay, means a graph is bipartite means what? Means does not have any odd cycle. If and only if no odd cycle, no odd cycle, no odd length cycle. So each component also should not have odd length cycle. If I give you this graph A, B, C, then this graph G, this is bipartite. This graph G is bipartite, and this partition will also work. See, this partition will also work. This partition will work. This partition will also work. This partition will also work. Okay, all these partitions will work. So bipartite means you can create a partition. You can create a bipartition. So is this clear? So G is bipartite if and only if no odd cycle. So basically every component also should be bipartite. G is bipartite if and only if every component. Here this component is not bipartite. Here every component is bipartite. This component bipartite. This component is bipartite. This component is bipartite, and this component is also bipartite. So G is bipartite if and only if every component is bipartite. Okay. So these concepts, are they clear? Like maximum number of edges in bipartite graph. How to find that? Maximum number of edges in a bipartite graph. And if you have a graph in which you have more than n by 2 whole square edges, then that graph is not bipartite. So this statement they can ask. If you have a graph in which n vertices graph with more than these edges, then it is not a bipartite. Okay. So that's the idea. Now let's see the next, that is hypercube graph. Are they bipartite? Let's see all of them. Which of them is bipartite? Tell me. All the categories, which is bipartite? Which graph are bipartite? For example, the first, can I say Kn is bipartite? The second, Pn, path graph. The third, Cn. The fourth, Wn. Okay. The fifth, En. And the sixth, Qn. Which of these graph is bipartite? The 7, Km, N. Okay, so tell me which graph is bipartite. So you can notice there is no odd cycle. So this is bipartite. There is no odd length cycle. There is no odd length cycle in a path. In a path, there is no odd length cycle. So basically, which graph is bipartite? Just see which have odd length cycle. If and only if no odd cycles, no odd length cycles. Okay, this complete bipartite, this is bipartite. Okay, only for, this is bipartite only for n equal to 1, 2. This is bipartite only for 1 comma 2, n equal to 1 comma 2, this, else this is not bipartite. Bipartite only for n equal to 1 comma 2. What about this? This is also not bipartite only if n is even. Only if n is even. Next, what about wn? What about wn? What do you think? What about wn? This is not, because in wn what happens? Just see what happens in wn. In wn you have this vertex, and because of this vertex a triangle will create. Yes or no? In wn this type of situation will happen. So you are getting a odd length cycle. In wn, if you notice this wn, then in wn you will get a odd length cycle. You will definitely get a odd length cycle, whatever wn you take. In every wn, for example, in every wn, what will happen? This middle vertex will create a odd length cycle. So very simple. So because you are getting an odd length cycle, so this is, you are getting an odd length cycle. So wn is not bipartite. What about en? This is bipartite. What about q? This is your complete bipartite graph. So this is also, and this hypercube is also bipartite. This hypercube graph is also bipartite. Why? What is the reason? Let us see. This qn. What is this qn? This is your hypercube graph on how many vertices? Hypercube graph on how many vertices? This is hypercube graph on 2 power n vertices. Okay, so this is the idea. Now, this hypercube graph on 2 power n vertices, this is actually bipartite. This is actually bipartite. You can create a bipartition. How to create a bipartition? Let me tell you. Very simple. What you can do, if you want to create a bipartition, what you can do? You can use the parity. The concept of parity you can use. What you can use? For example, what is parity of a string? What is parity of a bit string? What is parity of a bit string? That is number of ones. That is number of ones in it. That is number of ones in it. Okay. So very simple. What is parity? Parity of a bit string. If I give you a bit string, for example, if I give you this bit string, then what is the parity of this bit string? What is the parity of this? That is 3. Or I can say actually that is odd. Parity is odd or even. Parity is odd or even. I can say basically parity is odd or even. Remember, parity is odd or even. This parity is odd or even. And that is basically defined by, that is based on number of ones in it. Okay, so that will be odd or even. So this string has parity odd. What is the parity of this string? This string has parity even. What is the parity of this string? Number of ones is even. What is the parity of this string? Number of ones is odd. What is the parity of this string? Number of ones is even. What is the parity of this string? Number of ones is odd. So parity is odd or even. Is this clear? Parity is basically odd or even. Very simple. Either it will be odd or it will be even. Now what you can do, if you want to create a bipartition of this qn hypercube graph, then what you can do? This is very simple. You can put odd parity strings here. You can put odd parity strings here, and you can put even parity strings here. Tell me, can you have age between two odd parity string in hypercube graph? In hypercube graph, can you have age between two odd parity strings? Can you have that between two odd parity strings? Just think about it. If I give you, like, okay, if I give you some string, then this will be adjacent to whom? This will be adjacent to whom? Just tell me. This will be adjacent to odd parity only. Whatever you do, you will get odd parity. See, this will be adjacent to, you can notice whatever bit you change, this will be adjacent to only odd parity strings. This will be adjacent to only a odd parity string. Because if I change this, then I will get odd parity. If I change this, I will get odd parity. If I change this, odd parity. If I change this, odd parity. So whatever I change, this will be adjacent to only odd parity string. So I can say that If you have even parity string, then they can never be adjacent. Yes or no? Even parity string, they are not adjacent. They are not adjacent, I can say. Yes or no? Not adjacent. Similarly, odd parity string, they cannot be adjacent. For example, if I put 0, 0 here, like I am putting odd parity means 0, 1, 1, 0, and even parity means this. So now you can notice this is adjacent to this is adjacent to this, and this is adjacent to this is adjacent to this. Is this clear to everyone? This concept, is this clear? That hypercube graph is actually, for example, this Q3. Look at this Q3. This Q3 is also bipartite. Okay, for this Q3, what you can do? You can put odd parity strings here, or you can put even parity strings here. So, for example, even parity strings, you can put this even parity string here. You can put this even parity string here. You can put this even parity string here and this here. And here you can put odd parity strings like, okay, 1, 0, 0, 0, 1, 0, 0, 0, 1. Now you can notice that they are non-adjacent. Yes or no? They are not adjacent, correct? They are not adjacent. You can notice. None. Are they adjacent? For example, these two, are they adjacent? Tell me. In Q3, they are not adjacent because they are changing in two positions. The Hamming distance is 2. They are changing in two positions. These two are not adjacent. These two are not adjacent. They are also changing in two positions. Okay, they differ in two positions. So finally, what I can say, like this, I can say, this is adjacent to whom? This is adjacent to this. This is adjacent to this, and this is adjacent to this. Correct? Similarly, this string is adjacent to this. This string 1, 0, 0. Okay. So this is adjacent to this one, and this is adjacent to this one. Yes or no? Like this you can do. Similarly, this string will be adjacent to this one. This string will be adjacent to this one and this one. Okay, so like this you can do. And last, this 0, 0, 1, this 0, 0, 1, where, okay, this 0, 0, 1, this will be adjacent to 0, 0, 0. This will be adjacent to 0, 1, 1, and this will be adjacent to 1, 0, 1. So this is the idea. Okay, I hope this is clear. So what we can do, remember, hypercube graphs are bipartite, and what we are doing in hypercube graph, what we are doing. So why they are bipartite? Because what you can do, all the odd parity strings you can put in one part, and all the even parity strings you can put in another part, whatever hypercube graph you take. So this is the idea. I hope this is clear. So remember, Qn for all n is bipartite. Is bipartite. And the partition, this Qn, actually I can write like this: G, where this will be the partition. Odd parity strings, you can put odd parity strings in one part. You can put even parity strings in another part. Okay, and these will be the edges. So I can say this whole thing, this is the partition of vertex set. This is part A, this is part B. Part A, part B, you have. Okay, so this will be your part A. Okay, and this will be your part B. So you have two part A, part B. And you can notice that this is the bipartition of a Qn. Okay. This Qn, can I say this is complete bipartite graph Qn? Can I say this is complete bipartite graph? Can I say this is complete bipartite graph? No. Complete bipartite graph, the answer is no. You can notice this Q3, you can notice this is not complete bipartite graph. This is not complete bipartite graph. Yes or no? Correct? Next. This is your GATE exam question. What will be the answer? Maximum number of edges in bipartite graph on 12 vertices, that will be 36, because If this is your n, then the maximum number of edges, the answer will be n by 2 floor multiplied by n by 2 seal. This will be the answer. This will be the maximum number of edges in bipartite graph on n vertices. So very simple question. Okay, so if you want to get this 36, then what you have to do? You have to put these 6 vertices here. You have to put 6 vertices here, and you have to put 6 vertices here. You will get an answer. Okay, next, let me tell you one more thing. Normally, in graph theory, normally in graph theory or some other subjects, whenever they ask you maximum, minimum, normally in graph theory or in some other subjects, whenever they ask you maximum, minimum, where these are found, maximum comma minimum are generally found where? Are generally found at the corner cases. Are generally found, remember, they are generally found either at the corner cases, either at extreme corner, extreme partial distribution, or symmetric distribution. Either extreme partial distribution, either extreme partial distribution or extreme fair distribution. Extreme fair distribution. So what I'm saying, either extreme unfair distribution or either extreme fair distribution. Either you do extreme unfair distribution or you do extreme fair distribution. Okay, this is a simple thing. Like this will happen. This will happen. You can check it out. Okay, like in mathematics also many times this will happen. I am not saying this will always happen. This will not always happen. In mathematics, when you study calculus, when you study engineering mathematics, there are many questions you will get where this will not happen. But in all other subjects like operating system, DBMS, graph theory, algorithm, or whatever the subjects, like I can say non-mathematical subject, like okay, in engineering mathematics, in calculus, this will not true. This will not be true. Okay, because there we study many questions. You will solve 100 questions. In 100 questions, for almost 50-60 questions, this will be true. If you solve 100 questions, then almost 50-60 questions, this will be true. But in graph theory, in operating system, DBMS, in TOC, theory of computation, there if you solve these questions, maximum, minimum questions, if you solve, then mostly this will happen. Okay, like either you do extreme unfair distribution or you do extreme fair distribution. So for example, for bipartite graph, which is working, which is giving maximum, for bipartite graph, which is giving maximum number of edges, the maximum number of edges which is giving number of edges. So if you want to find maximum number of edges, then you can check these possibilities. Either you can check extreme unfair, like all n vertices here, this is empty, and this is all n vertices, like all the n vertices are here. This is extreme unfair, yes or no? And you can also check these, like n minus 1 vertices we are putting here. You can also check this. Or you can check n by 2, or you can check n by 2. So these things you have to check. Are you getting my point? So whatever question they give you, these cases you need to check. This is extreme unfair. This also you can check, where one vertex on one side and the remaining vertices. And this is fair. This is very fair. Okay, so this is the idea. So you can notice this unfair, this will give you minimum number of edges. For this particular question, this will give you minimum number of edges. Yes or no? For this particular question, this unfair distribution will give you minimum number of edges, that is 0. And this fair distribution will give you maximum number of edges, that is n by 2 whole square. Okay, is this point clear? So this is a, I can say this is a guideline. Okay, this is guideline mostly. I can say this is mostly this will happen. Okay, either you do fair distribution or you do unfair distribution. So on corner cases you have to check. You don't have to check. For example, if I give you, like if I give you 8 vertices, if I give you 8 vertices bipartite graph, then if I give you this 8 vertices bipartite graph, then you only have to check these, only have to to get maximum number of edges. And our question is to get maximum number of edges, So what you have to do, what you have to check, please tell me what you have to check. Actually, now you know the answer, but if you don't know the answer, now you know the answer. The answer you know. The answer is 4 whole square. But if you don't know the answer, then what are the cases you need to check? These extreme cases you need to check. Like all the 8 vertices here. Like these cases you have to check. Like all the 8 vertices here, 0 vertex here. Or you can check this case where 1 vertex here, 7 vertices here. Or you can check this case where 4 vertices, 4 vertices. So only these cases you have to check. On these corner cases, I can say these are the corner cases. These are the extreme, like unfair or fair cases, corner cases. So in these corner cases you have to check. You don't have to check like this, like, okay, you don't have to check like this. For example, 3 here, 5 here. You don't have to check like that.